Algebra 2, Lesson 5.5, Complex Numbers and Roots. In this section, we're going to be looking at the graphs of quadratic functions where it does not cross the x-axis, and we're going to learn how to solve those problems. So given the graph, or the function f of x equals x squared plus 1, so I'm going to sketch that real quick. So the y-intercept in the vertex is 0, 1. It's positive, so it opens up. So this graph does not cross the x-axis. It has no zeros. So what we're going to talk about today is how do we solve these problems that do not cross the x-axis. Here's another example. So if we have this problem right here, x squared plus 16 equals negative 9. If we want to solve this, we want to solve for x squared. So we need to get rid of the 16, and we subtract it from both sides. Then we have x squared equals negative 25. Now we can take the square root of both sides, and if you were to type this in your calculator, it would probably tell you error or non-real answer. But we're going to learn how to solve this today. When you try and take the square root of a negative number, it's a non-real answer. So here they call it an imaginary number. So the imaginary number is I, and I is defined as the square root of negative 1. So anytime that you see, if you try and take the square root of a negative number, you can replace that with the letter I. Right, an imaginary number is the square root of a negative number. So example A, this is your definition. What is the square root of negative 1? The square root of negative 1 is I. So your answer to letter A is simply I. So we're going to use this definition to solve the rest of these problems. So B, we have the square root of negative 2, and what I'm going to do is split this up into the square root of negative 1 times 2, and then split it again, square root of negative 1 times square root of 2. This first part, right here, the square root of negative 1, that's going to become I. And then we're not going to want decimals, so we'll leave this as the square root of 2. So here is your simplified answer to B. On C, the square root of negative 4, we're going to split it into the square root of negative 1 times the square root of 4. So the square root of negative 1 is I, and the square root of 4 is 2, and then we just want to write it the other way. The letter comes first, I comes second, just like if it was 2x, 2i. Now we've got I squared. So I squared, if you want to change this to the square root of negative 1 times the square root of negative 1. What is the square root of negative 1 times the square root of negative 1? When you have a square root and you multiply it by itself, your answer is going to be whatever's under the square root. So in this case, the square root of negative 1 times the square root of negative 1 will be negative 1. So this right here, you're going to want to remember this because we'll use it later on. It's I squared. You can almost treat it like a definition. We have this right here, the square root of negative 1 equals I, and I squared equals negative 1. So these two right here would basically be the definitions that we're going to use in later problems. Example 1, we're going to be simplifying square roots with negative numbers. So for most of these problems, the square root or the negative sign that's inside the square root, we're going to move that outside, make it an I, and then solve these just like we've solved square root problems in the past. So you might want to pause right now and write down that list of squared numbers on the bottom of the screen. I didn't write down 1 squared, but then it's 2 squared all the way through 12 squared, and those are the numbers I'm going to use to try and simplify these problems. So the first one we have, it's going to be negative because there's a negative out front. The square root of 96, I need to find one of these perfect squares that goes into 96, and it looks like it's going to be 16, and 16 is going to go in there 6 times, and then I'm going to put the little drop down part on the square root to signify the end of it, and then I took this square root out right here, or excuse me, this negative sign, and it became I. So getting rid of the square root on the inside, then I split 96 into 16 times 6, and now we'll have negative, the square root of 16 is 4. Then I want to write the I with the real number there, and then the square root of 6 stays in. B, we're going to have 2, this right here, the negative is going to become I, and then the square root of 36 is going to be 6, so we'll have 2I times 6, and then I can multiply the 2 and the 6. 2 times 6 is 12, so this one is simplified to 12I. Same thing here, the negative inside the square root becomes I, so we'll have 5I. The square root of 121 is 11, so we'll have 5I times 11, and 11 times 5 is 55I. So the last problem here, we've got negative 1/3. The negative inside the square root becomes I, and then what goes into 63 off a list of our perfect squares? It's going to be 9. 9 goes in there 7 times. So now we have negative 1/3 I. The square root of 9 is going to be 3. And then the square root of 7 can't be simplified anymore, so it's going to stay inside the parentheses. And the last thing we're going to do is take negative 1/3 times 3, which is going to be negative 1, and negative 1I. Alright, so these problems are going to be very similar to the ones before. The only difference here is instead of just straight simplifying, we're going to solve. And because there's no b term in any of these problems, that's why I'm going to put all the numbers on one side and then square root. So the first one's already set up for us. We've got x squared by itself, and we've got the number on the other side by itself, and we're just going to square root both sides. The square root of x squared is x, and the square root of negative 144. When we're solving equations, we're going to have positive and negative answers. The square root of a negative number is going to be I, and then the square root of 144 is 12. So this one will be positive, negative, 12I. B, we want to get the 90 to the other side, and then divide both sides by 5, and then we'll square root both sides. So first thing we want to do is subtract 90, and I'm doing this because there's no b term. 5x squared equals negative 90. Divide both sides by 5. X squared equals negative 18. Square root of both sides. Now I've got x equals positive negative I, and I can split 18 up into 9 times 2. Final answer, x equals plus and minus. The square root of 9 is 3, so it'll be 3I square root of 2. And I solved these problems this way because there was no b term. So when there's no b term, put all the numbers on one side, square root. Alright, so we're going to switch gears a little bit and talk about complex numbers. And a complex number is going to be a combination of a real number. So A indicates a real number, and then the B times I, that's the imaginary part. Even though B is going to be a real number, the I is the square root of a negative 1. So what we need to know here is what a complex conjugate is. And the word conjugate refers to when you have a square root, you have a positive and negative answer. So on the previous page, we took the square root of 144, and it was positive negative 12. That's what conjugate indicates. We're going to have a positive and a negative answer. So here's the square root of 10, and it's positive. Here's the square root of 10, and it's negative. So when we take a square root, we're going to have one positive, one negative answer. Negative 5 was the same in both of these. The only thing that changed was that second part. When finding complex zeros of quadratic functions, right now all we're doing is just writing the complex conjugate. It's this I part. Remember that the I is the square root of a negative 1, and we're going to have a positive and a negative square root. So what's the complex conjugate here? It's the negative of the square root. So 5i, that means the square root of negative 1. We're also going to have 8 minus the square root of 5i. Over here we have 6i. So the complex conjugate of a positive 6i is a negative 6i. And the last thing we're going to do today is solve these functions by completing the square. So we need to work on completing the square, and then the only difference between yesterday's lesson and today is we're going to have some square roots and negative numbers here. Alright, so we want to set this equal to 0. X squared plus 10x plus 26 equals 0. Now we want to get rid of the c term. So I left a little bit of space right there so we can do half of the middle term squared. So we're going to do plus half of the middle term squared. We want to add that to both sides. So x squared plus 10x. 10 over 2 is 5. 5 squared is 25. So we've just created a perfect square trinomial, and this equals minus 26 plus 10 over 2, that's going to be negative 26 plus 25 is negative 1. So now that we've created the perfect square trinomial, we can use the shortcut to factor. And then when we solve this, we take the square root of both sides. So the square root of x plus 5 squared is x plus 5 equals the square root of negative 1 is going to be positive negative I. And last step, just subtract 5 and we'll be done with this problem. So right here, the I and the negative 5 are not like terms. It's like a variable. Negative 5 is a number, and then I is kind of like your variable. So we can't put these together, but you have x equals negative 5 plus and minus I. Alright, same thing on B. We want to set it equal to 0. So we'll have x squared plus 4x plus 12 equals 0. Get rid of the c term. Now we have to do half of the middle term squared. So that's going to be plus 4 over 2 squared, and over here plus 4 over 2 squared. So we've just created a perfect square trinomial. So x squared plus 4x plus 4 divided by 2 squared, that's going to be 2 squared, which is 4. Now that we've created a perfect square trinomial, we can factor it. X plus 2 squared is the first part, equals negative 12 plus 4 is negative 8. Square root both sides. X plus 2 equals positive negative. The square root of negative 8 is going to be an I. And then we can split 8 up into 4 times 2. The square root of 4 is going to be 2. This has to stay inside because we can't square root that and get a nice number. And then our last step will be to subtract 2 from the first part of the equation. Now we have x equals negative 2 plus and minus 2I square root of 2. Alright, that's it for this lesson.